Good morning, everyone. I'm Limon Jose Anthony D. Francisco, a mechanical engineering student of CPU. For today's lesson, we're going to discuss integration using U substitution, integration by parts, using trigonometric substitution, using partial fraction, and double and triple integrals. Learning objectives. Many integration formulas can be derived directly from their corresponding derivative formulas, while the other integration problems require more work. Some that require more work are substitution and change of variables, integration by parts, trigonometric integrals, and trigonometric substitution. Principles of integration. One of the integration techniques that is useful in evaluating indefinite integrals that do not seem to fit the basic formulas is substitution and change of variables. This technique is often compared to the chain rule for differentiation because they both apply to composite functions. In this method, the inside function of composition is usually replaced by a single variable, often u. Note that derivative or a constant multiple of the derivative of the inside function must be a factor of the integral. For the first lesson, we use substitution. Integration by substitution, also called U substitution, or the reverse chain rule, is a method to find an integral but only when it can't be set up in a special way. And this is our first example. We're going to solve the integral of 4x times x squared plus 5 raised to 3 dx. We're going to find and substitute u to x squared plus 5 and du to 2x dx. For the first part, we're going to substitute the integral 4x times u raised to 3 du 2x is equal to 2 the integral of u cubed du is equal to 2 times 4 over 4 raised to 4 plus the constant, and 1 half u raised to 4 is equal to 1 half x squared plus 5 raised to 4 plus the constant. That will be your final answer. For number 2, we're going to solve the integral of 8 cosine times 4x dx. So we're going to substitute, let u be 4x and du be du over 4. To solve it, we're going to substitute in the equation, so meaning we're going to have the integral of 8 cosine times u du over 4 transpose 2 times the integral of cosine u du 2 sine u plus the constant, and we're going to return the value of u, so the final answer will be 2 sine times 4x plus the constant. Integration by parts. Integration by parts or partial integration is a process that finds the integral of a product of functions in terms of the integral of product of their derivative and in their antiderivative. And this will be our example. The integral of x sine x dx. We're going to substitute u for x, du for 1 dx, v for cosine x, and dv for sine x dx. For the first part of the formula, we're going to have the integral of u dv is equal to uv minus integral of v du. So we're going to follow that by substituting the value. X times cosine x plus the integral of cosine x times 1 dx. Simplify. Negative x cosine x plus the integral of cosine x dx. And the final answer will be negative cosine x plus sine x plus the constant. For number 2, we're going to solve x squared ln x dx. Let u be ln x, du will 1 over x dx, and v is 3 cube x cubed over 3, and dv will be x squared dx. As like for number 1, we're going to follow the formula, and we will going to get the ln x times x cubed over 3 minus the integral of x cubed over 3 times 1 over x dx. We're going to solve the first part, which will be 1/3 x cubed ln x minus 1/3 the integral of x squared dx. And we're going to simplify, so the answer will be 1/3 x cubed ln of x minus 1/3 times x cubed over 3. And we're going to simplify even more, so we're going to have the answer of 1/3 of x cubed ln of x minus 1 over 9 x cubed plus the constant. Trigonometric substitution. Trigonometric substitution is the substitution of trigonometric functions for other expressions. In calculus, trigonometric substitution is a technique for evaluating integrals. For this lesson, we're going to solve the integral of dx over x squared times the square root of 4 minus x squared. Let x be 2 sine dx is equal to 2 cosine. For the following, we're going to have the first part, which will be integral of 2 cosine over the square root of x squared times 4 minus x squared. We're going to substitute the denominator. We're going to have 2 cosine over the, we're going to cross out, so we're going to have the 1/4 times integral of 1 cosine, and we're going to simplify. So we're going to have the answer of negative square root of 4 minus x squared over 4x plus the constant. For number 2, we're going to solve dx over x squared plus 4 raised to 3 over 2. We're going to have tan x over 2, and x is 2 tan, and dx is 2 sec 2 cosine 2 over x squared plus 4. First, like for the first part, we're going to do the same like number 1. So we're going to cross out and simplify and exchange what we substitute and add the constant. Using partial fraction. Integration by partial fraction is a method used to decompose and then integrate a rational fraction in integrand that has complex term in the denominator by partial fraction. We calculate and decompose the compression into simpler terms so that we can easily calculate or integrate the expression thus obtained. For this, we were going to solve integral of 9x squared minus 32 x plus 5 double and triple integral. A double integral is a domain of 2 dimensions. A triple integral has domain of 3 dimensions. For this, we're going to solve the integral of a limit of 1 and 0 and the limit of y squared and 0 to e over y cubed dx dy. Let u be y cubed, du will be 3y squared dy, and dy will be du over u squared. Going to have 1 and 0 will be our limit, and e raised to y cubed times x with the limit of y squared and 0 dy. And we're going to simplify. We're going to have 1/3 e raised to y third y cubed with the limit of 1 and 0. And our answer will be e 1/3 times e minus 1. For number 2, we're going to solve the integral of 1 over 10 x raised to 10 dx is equal to 1 over 110 x 11 with the limit of 1 of 0, and your answer will be 1 over 110. Thank you for watching, and I hope you learned a lot.